Let's just draw a sketch of what's going on. We've got a piece of rope and Sam is holding it by its midpoint. I'm going to say this end is A and this end is B. And then another piece of rope, which I'll say the end is C and D. Pat chooses two of the loose ends at random, so two out of A, B, C, and D, ties them together. What's the probability that Sam now holds one untied length of rope and one tied loop of rope? So if Sam picks, sorry, if Pat picks A and C, then the whole thing would just be joined together. That wouldn't be an untied length of rope and a tied length of rope. We just get this with like a tie in the middle. So that would be A and C, for example. But if he went with A and B, then we'd end up tying this in a loop, them hold in the middle there, and then one that's still untied. So that one wouldn't count, that one would. Now what I decided to do in this question is draw a little sample space. Sorry, that should be, and perhaps it's overcomplicating it, but it was quite a safe method of doing it. So this is the first end picked, and this is the second. So we can't pick the same end twice. I can put crosses here. Now, if B is picked first and then A is picked, then that would count. Whereas if C is picked and then A, that wouldn't, and the same with D. If A is picked first and B is then picked, that would be okay, but then these wouldn't. Sorry, when I mean crosses, I mean like this just couldn't happen. Sorry, I should have made that clear, so I'm just going to just cross that whole thing out. Okay, then for C, it's going to be very similar. C goes with A, then nope. C with B, nope, because again, we just end up with this first case. But if C is picked with D, that would work. And then if D goes with C, that would work, but not any of the others. So we see in each row, we've got one tick and two crosses. If you count them all up, or you just can see there's going to be a 1 in 3 chance. Another way to do this question that's even quicker is to just say, right, it actually doesn't matter which one is picked first because there's symmetry going on in the problem. If B is picked or C is picked, you're still picking a rope that connects to something else and Sam is holding it in the middle. So let's just choose without loss of generality that B is picked. Then the only way that the second one would give a loop of rope is if A is picked. If C or D is picked, then it wouldn't work. So actually there's three choices after you picked your first one, let's say B, for example, and only one of them would lead to an untied length and a tied length. So that also must mean it's 1 over 3. That's quite a nice, well, that is the best approach because you don't have to draw a sample space, you just get the answer straight away. But you have to kind of convince yourself that it actually doesn't matter which one you pick first, it's going to be the same regardless.